The paper is High Performance Concurrency Control Mechanisms for Main Memory Databases. It's a 2012 paper. In this paper, authors introduce two efficient concurrency control methods specifically designed for main memory databases. Both use multi-versioning to isolate read-only transactions from updates, but differ in how atomicity is ensured. One is optimistic and the other is pessimistic. To avoid expensive context switching, transactions never block during normal processing, but they may have to wait before commit to ensure correct serialization ordering. Authors also implemented a main memory optimized version of single version locking. Experimental results show that while single version locking works well when transactions are short and contention is low, performance degrades under more demanding conditions. The multi-version schemes have higher overhead but are much less sensitive to hotspots and the presence of long-running transactions. Now let's look at the evaluation. Paper Prototype Storage Engine implements both the optimistic and the pessimistic scheme. They also implemented a single version storage engine with locking for concurrency control. The implementation is optimized for main memory databases and does not use a central lock manager, as this can become a bottleneck. The experiments were run on a 2-socket Intel Xeon X5650 with 2.67 GHz that has 6 cores per socket. Hyperthreading was enabled. The system has 48 GB of memory, 12 MB L3 cache per socket, 256 KB L2 cache per core, and 2 separate 32 KB L1I and L1D caches per core. This is a newer system and memory latency is asymmetric. That is, accessing memory on the remote socket is approximately 30% slower than accessing local memory. The operating system is Windows Server 2008 R2. Now let's look at the contributions of the paper. This paper makes 3 key contributions. First, they propose an optimistic MBCC method designed specifically for memory resident data. Second, redesign of 2 locking-based concurrency control methods, one single version and one multi-version, to fully exploit a main memory setting. Third, they evaluate the effectiveness of these 3 different concurrency control methods for different workloads. The insights from this study are directly applicable to high-performance main memory databases. That is, single version locking performs well only when transactions are short and contention is low. Higher contention or workloads, including some long transactions, favor the multi-version methods, and the optimistic method performs better than the pessimistic method. Now let's give this paper a PS score. It's a bit of a bumpy read, so it gets 8 out of 10 on readability. Length is 12 pages, which seems appropriate for the content, so it gets 9 out of 10. Reproducibility might be a challenge, so it gets 7 out of 10. Industry value is decent, so it gets 7 out of 10. Learning meter is high with some interesting results, so it gets 8 out of 10. So the overall PS score is 8 out of 10.